Bismillah Rahman Rahim. In this session, we will discuss general properties of wave from O level and IGCSE physics book, and written by Tom Duncan and Heather Kennett, published by Order Education in year 2021. And this is one of the highly recommended book for O level students. Waves are disturbances which carries energy from one place to another. So wave is considered as a disturbance, but it carries energy from one place to the other without transferring matter. So matters are not transferred, but energies are transferred. So waves are disturbance which carries energy, which transfer energy from one place to another without transferring matter. So there are two types of waves. One is called transverse waves, the other one is known as longitudinal waves. So the type of wave motions, several kind of wave motions occurs in physics. Mechanical waves are produced by disturbance such as a vibrating object. We use a vibrating object in a material medium and transmits by the particles of the medium vibrating about a fixed position. Such waves can be seen or felt, include waves on a rope or a spring. So these waves can be produced, can be seen, can be observed, or can be felt on a rope or a spring. Water waves and sound waves in airs or in other materials are also observed. A progressive waves or traveling waves. Progressive waves or a traveling wave is a disturbance which carries energy from one place to another without transferring matter. It carries energy. It carries energy. It carries energy from one place to another without transferring matter. So keep it in mind that energy is transferred but matters are not transferred. So there are two types, transverse waves and longitudinal waves. So let's study the transverse waves. In a transverse wave, the direction of disturbance is at right angle to the direction of propagation. So the direction of waves is this, is on the x-axis, and to the direction of propagation of waves. So direction of wave is this, and the direction of vibration is this. So here we have this wave is producing in this rope. So there is a hump or a hollow or a crest or a trough. So this is a vibration is perpendicular and the direction is this. So they are in 90 degrees. So this angle and this side is a 90 degree, and this is called a transverse wave. This kind of wave is transverse waves. The direction of disturbance is this. This is the direction of disturbance, but the propagation of wave is in this direction. So the propagation of wave is in this direction, and the disturbance is occurring in this direction on a y-axis, and wave is traveling on x-axis like this horizontally. So this is orthogonal or perpendicular or at right angle to the direction of propagation of wave, that is the direction in which the waves travel. A transverse waves can be sent along a rope like this rope or a spring. Similar kind of spring can also be used by fixing one end at this time and moving the other rapidly up and down. So this is one of the way the transverse waves are being produced in this rope. The disturbance generated by the hand is passed on from one part of the rope to the other, one part of the rope to the next, which perform the same motion but slightly later. So this way it is transferred. The hump and hollow of the waves travel along the rope as each part of the rope vibrate transversely about its undisturbed position. So this was the undisturbed position. This is the undisturbed position. The exact horizontal position is the undisturbed position, and this is the disturbed position. So disturbed position, this x-axis is the undisturbed position. If this rope is straight in a straight line, that's undisturbed position. This is undisturbed position, but this is a disturbed position. This is disturbed position. From the undisturbed position to disturbed position. So the hump and hollow of the waves travel along the rope as each part of the rope vibrates transversely about its undisturbed position. So every particle, every points is vibrating transversely. Water waves can be modeled as a transfer waves or can be as a seismic S waves. Seismic S waves, moreover, electromagnetic radiations are also transfer waves. Next, see the longitudinal waves. In a progressive longitudinal waves, the particles of the transmitting medium vibrate back and forth along the same line as parallel to that in which the wave is traveling, and not at right angle to it as in a transfer wave. Here the propagation of wave and the disturbance are in the same direction. So the direction of disturbance is same, pressing, compressing or expanding, and the wave motions are in the same direction. So a longitudinal wave can be sent along a spring stretched out on the bench and fixed at one end. If the free end is repeatedly pushed and pulled sharply as shown in figure 3.1. So pushed and pull. So in this way, some compression where the coils are closer together like this is called compression, and where the coils are further apart is called rarefaction. The rarefaction, this is rarefaction and this is compression. So compression, rarefaction, compression, rarefaction. In this way, this longitudinal waves travel along the spring. So this is a longitudinal wave. Here the direction of disturbance and the direction of propagation are same, unlike the transfer wave, where the direction of propagation and the direction of disturbance are orthogonal or perpendicular or at right angle, but here they are in the same position with zero angle, parallelly or in the same direction or with zero angles. So compression and rarefaction has shown. Moreover, sound waves and seismic P waves are examples of longitudinal waves. Seismic S waves are transfer waves. Seismic P waves are longitudinal waves. So there are seismic waves contains both types of waves, transfer waves and longitudinal waves. S type of waves are transfer waves, while seismic P types of waves are longitudinal waves. So keep in mind, this part may be asked in a MCQs section of O-level exam or IGCSE exam. Now this describing waves. We will describe wave in the